We shall now look at generalized binomial theorem. When you have 1 plus a power n, here n need not be a positive integer. So here n can be half, n can be like minus 3/4, n can be negative 1. Okay. And it's just 1 plus na. If you write 1 plus a power n, it's just 1 plus na plus n times n minus 1 over 2 factorial a squared and n minus 1 n minus 2 over 3 factorial a cubed. So that means instead of using NCR, you use the generalized binomial coefficients. Okay. And you'll find you need a to be between minus 1 and 1. So the expansion is only valid for a between minus 1 and 1. And previously we know that 1 over 1 minus x can be expanded as 1 plus x squared, x cubed, and so on, with x between minus 1 and 1. So that's what we have done the other time, last week. So 1 over 1 minus x is 1 plus x squared, and so on. And you need x between minus 1 and 1 for the expansion to be valid. So for the generalized binomial theorem, for the expansion to be valid, you need a to be between minus 1 and 1. And let's look at 1 over 1 minus x. If you approximate 1 over 1 minus x by x, 1, x squared, x cubed, and x power 4, if you choose a number 1/3, 1/3 is between minus 1 and 1. So if you sub inside the left hand side, 1 over 1 minus x. So 1 over 1 minus x. If you sub x as 1/3, left hand side gives you 1.5. Right hand side, if you stop at x power 4 term with x as 1/3, you'll be summing all these fractions. It gives you 121 over 81, which is 1.494. So it's still close to 1.5. And if you need a more accurate answer, then you can consider to put in the x power 5 term, x power 6 term. The more term you use, the more accurate approximation you'll get. Okay, let's look at an example. We also find the first 3 terms of this expansion. 1 over square root of 4 plus 3x. First, you take note that 1 over square root, right? X. Square root x is x power half. So 1 over square root x should be 1 over x power half. So it can be written as x power minus half. So that's why you can write it as power minus half. Okay, and 4 plus 3 over x. 4 plus 3x. We can take out 4 and write it as 1 plus 3x over 4. Okay, so if you raise to power half, if you raise to power minus half, then it's the whole thing you raise to power minus half. And then you can write it as 4 power minus half. 1 plus 3x over 4 power minus half. You know that when you have ab power n, is a power n, b power n. So you use that, you can split it as 4 power minus half. 1 plus 3x over 4 power minus half. So that's how we end up with this. And then you can focus on 1 plus 3x over 4 power minus half. So you consider 1 plus a power minus half. And a is actually 3x over 4. So a is actually 3x over 4. So we go back to what I have done earlier. We look at the formula for binomial coefficient, generalized binomial theorem. If you write 1 plus a power n, then you write down 1 n times a, n minus 1 over 2 factorial a squared, and so on. So it means you need to sub n as minus half in the example we are looking at now. So you sub n as minus half. Okay, you sub into the formula. You get 1 minus half a plus 3 over 8 a squared. Okay, then a is 3/4 x. So you get 1 plus 3x over 4 power minus half. You sub a as 3/4 x. And then you can give you this expression. So with that, right, remember outside there's a 4 power minus half. 4 power minus half is actually 1 over 4 power half. 4 power half is square root of 4. Square root of 4 is 2, so it means it's half. So that's why there's a half here. This half is because of 4 power minus half here. Just now we took out a 4 to make it 1. You must make it 1 plus something so that you can apply the generalized binomial theorem. Okay, so you must write the half in. Eventually this will be the expansion you are looking at. So this is the expansion for 1 over square root of 4 plus 3x. And remember there's a constraint. Remember the expansion is only valid for a between minus 1 and 1 if you write at 1 plus a power n. So which means if you look at 1 plus 1 over square root of 4 plus 3x, since you write it this way, this time you write it this way, you write it as 1 plus 3x over 4 power minus half. Right? So which means you need 3x over 4 between minus 1 and 1. And this is same as x between minus 4/3 and 4/3. Okay, let's try to sub in some numbers and see what happens. If you sub x as 1, inside here you'll be 1 over square root of 4 plus 3 bracket 1. So it gives you 1 over square root 7. So you sub x as 1, and it's fine to sub x as 1 because 1 is within the range minus 4/3 to 4/3. And if you sub x as 1 into the right hand side, the three terms, half 3 over 16x and 27 over 256x squared, you'll find it gives you this number, 107 over 256. So it means this is about same as 1 over square root 7. You use it to approximate 1 over square root 7. So if you invert it, then you can approximate square root 7 by 2.393. If you work out square root 7 from the calculator, it's 2.646. So you'll find the approximation is not accurate. And the reason is because, there are two reasons. One is because you start with x squared term. If you use small term, it needs to be more accurate. Another reason is because x equals to 1 is quite big. Later you'll find that we submit a smaller number, then you'll get a better approximation. Let's try the next example. Let's try other numbers. Instead of 1, we try to sub x as 1/3. If you try to sub x as 1/3 here, it may be 1 over square root of 4 plus 3 bracket 1/3, right? So it give you 1 over square root of 4 plus 1. So it gives you square root 5. 1 over square root 5. And if you sub x as 1/3 onto the right hand side, this time it gives you 15 over 256. So that means this is about 1 over square root 5. And so square root 5 will be the other way around. And you'll find that square root 5 is 2.326. But if you look at what you get, right, is actually 2.226. It should be 115 here. Just be 115 over 256. Okay, then you get 2.226. So you take note there's a typo here. One is 115 over 256. So that means square root of 5 is actually can be approximated by 2.226 if you use 1/3, x is 1/3, and you start by x squared term. So you'll find this side is more accurate. Square root of 5, the actual value is 2.236, and you use only until x squared term with a smaller x at 1/3, you get the first two decimals 2.2, 2.2, 2.3, so it's actually quite close already. Okay, let's do another one. This time you sub x as 1/4. This time you sub x as 1/4. And you'll find that if you sub x as 1/4, left hand side will give you 2 over square root 19. Right hand side will give you this number, 1883 over 4096. So which means this is about 2 over square root 19. And then you can work out, you can work out square root 19, it should be 8192 over 1883. It can be approximated by this fraction, which is 4.351. And if you key into the calculator, square root of 19 gives you 4.359. So you'll find that the first two decimals agree. So you'll find that the smaller the number you use to approximate terms like or like square root of 19, square root of 5, square root of 7, the smaller the number you choose, the more accurate the approximation you have.